In the last video, we talked about classical conditioning. Today, we're going to talk about operant conditioning. And we're going to talk about two sort of developments in the understanding of operant conditioning. We're going to talk about the law of effect that was talked about by Thorndike, and we're going to talk about operant conditioning as further developed by B.F. Skinner. Now, in classical conditioning, the main thing that was learned was a new association. A conditioned stimulus now produces a conditioned response where prior was neutral. Here we're talking about not actually learning new behaviors with operant conditioning, learning a behavior that wasn't in the repertoire of behaviors prior to the conditioning. Now, in Thorndike's case, he actually put cats in these boxes that if they pulled levers and turned knobs and did kind of things, they would open the door to the puzzle box, and there would be food that the cat couldn't reach without opening the door to the puzzle box. And the cat was put into the box, and it obviously explores things. It doesn't just sit there. It explores and touches things and tries to get to the food. And eventually, through trial and error, it'll actually put his paw and open that switch and pull the right string, and the door will open, and the cat gets the food. And here we have the time that the cat spends in the box across trials, putting the cat in the box. And as you can see, eventually the cat stays in the box for a very short period of time because it opens the door and it actually has learned what it takes to open the door to get to the food. Now, he called this the law of effect. If behaviors are developed that produce pleasurable outcomes, then the effect of that pleasurable outcome will strengthen that behavior. The behavior of opening the door to the box by turning the switch and pulling the string. The law of effect. This was further developed by Skinner in using what's often called a Skinner box. He called it the Operant Chamber. An animal was placed in this box, and it has several features to it. It has a lever that the animal can press this lever, and if we are conditioning the pressing of that lever, then that would lead to food being released in the food dispenser. Animal presses the lever, gets food. Then there are also things in the box that can produce other kinds of stimuli. There's a loudspeaker to produce sound. There are lights of different colors to use as stimulus control to produce the response only when the stimulus is present. And there's an electrified grid in the floor of the box so that the shock can be administered if you wanted to use punishment. So if I was just training the lever, the animal, again, just like the cat in the box, is not going to just sit there. It's going to wander around touching things, sniffing things. And eventually it hits his paw or his nose against the lever, and the lever dispenses food in the food dispenser. And, of course, then we can actually watch, just watching that, the animal will start pressing the lever to get to the food. We might want to say, might want to have discrimination. So we'll only provide food when it presses the lever when the green light is on. If the red light is on, the lever will not lead to. So eventually we'll have stimulus control, and when the green light comes on, then the animal will press the lever and get the food. Operant conditioning. There are two things we can do. We can reinforce the animal or the person. That's a stimulus that actually strengthens behavior, like the food for the rat, chocolate for me. Something that you find pleasurable will strengthen that behavior, the law of effect. We can also weaken a particular behavior by using punishment. And punishment is a stimulus, a negative stimulus, that weakens behavior. Reinforcement, strengthening behavior. Punishment, weakening of behavior. So reinforcement strengthens behavior, and I have positive reinforcement and negative reinforcement. Positive reinforcement is where I present a pleasant stimulus after the behavior occurs. The rat presses the lever, it gets food. Negative reinforcement is when unpleasant stimulus is removed after the behavior occurs. Again, we're strengthening behavior like pressing the lever, but now if I press the lever, then some unpleasant stimulus is removed. For example, if the animal is being shocked and now it presses the lever and the shock is removed, then I'm strengthening the behavior of pressing the lever. So positive reinforcement, negative reinforcement. I can also use punishment that weakens the behavior. And I can have positive punishment where a presentation of unpleasant stimulus after the operant behavior occurs. So if I press the lever and now I'm shocked, then it's going to weaken the behavior of pressing the lever. And I can also have negative punishment, is where I can remove a pleasant stimulus after the operant behavior occurs. So if, in fact, I'm receiving a pleasant stimulus and now it's removed after I engage in the behavior, then that behavior is going to be weakened. I like to think of my grandchildren playing in my house, and they're having fun playing, but they're also being very, very loud. And I might say, okay, time out. You're being too loud. Sit over here for 5 minutes in the corner. Time out. So I'm removing a pleasant stimulus of playing with their cousins. And by removing that pleasant stimulus, then I hope to reduce the noise that's made while they're playing. It works sometimes, but it's negative punishment. Now, I also, with operant conditioning, can engage in very, very complex behaviors. You've seen animals do tricks at circuses. Very complex behaviors can really be controlled by using operant conditioning. But I have to do it because sometimes these behaviors, like a rat doing a backflip, are not going to occur naturally, and so I have to somehow figure out how to do that by shaping the behavior, the method of successive approximations. So I might use shaping. Let's say I want to make the animal turn around completely. I might give the animal food only when it turns away from the lever. And then it turns further away from the lever towards the back of the cage, then I give it reinforcement. And if it turns around so that it's turned around far enough so that now when I give it food, it completes the circle, eventually I'll have the animal circling the box to get the food. I'm shaping a complex behavior by using successive approximations to the behavior I want to shape. Now, I'd like you to Google rats playing basketball on your computer, and you'll see some films of complex behavior. Rats actually going down the court and shooting hoops that had been shaped by really classroom kids learning about operant conditioning. So Google rats playing basketball and watch those films. It's a lot of fun. Just want to mention one other thing about operant conditioning. Olds found that if you put an electrode down in the hypothalamus of the brain, an area below the cerebral cortex, the hypothalamus. Hypothalamus is known to control motivation, feeding behavior, drinking behavior, pleasurable kinds of things. And I stimulate the hypothalamus, then the animal will engage in operant behavior to get that stimulation. In fact, it's a very powerful reinforcer. If the animal is hungry and I have one lever that goes to food and one lever that goes to stimulation in the hypothalamus, then they'll engage in pressing the lever to get the stimulation for long periods of time, thousands of trials. It's a very powerful reinforcing event. So he actually said this has something sort of like the pleasure center of the brain that I'm stimulating to produce very strong operant behavior. Now I want to talk a little bit about schedules of reinforcement, because I can have reinforcement at a particular schedule that produces particular kinds of strength of behavior. I think I mentioned earlier on the pretest that if you reinforce the animal in every trial versus reinforce the animal on only a partial number of the trials, that partial reinforcement will lead to stronger behavior than continuous reinforcement. And I can schedule in different ways. I can have ratio schedules where I reinforce on the basis of how many responses are made, a ratio. So a fixed ratio, for example, might be every fourth response I reinforce. It's every time the fourth response, pressing the lever, they get food. Or I could use a variable ratio where it's on the average. On the average, every 10th response is reinforced, but it might be 8 responses this time, 12 responses next time. Variable schedules lead to a higher rate of responding than fixed schedules, and I'll show you that in a minute. Then we could also have interval schedules where I don't use the number of responses, but a response after some interval of time passes. A fixed interval 10-second might be the first response made after a 10-second interval is reinforced, or it could be variable. On the average, the first response after some interval has occurred will be reinforced. And again, variable schedules lead to higher rate of responding than fixed schedules. Now, to show you this, I'm going to use a cumulative recording. This is a pen on a piece of graph paper that's running through a roller, and every time the animal makes a response, it blips up one notch. So the pen will go up one for this response, then it's flat. And then if the animal engages in rapid responses, and of course the slope of this will get higher. And then every time they get a reinforcer, then it indicates that on the recording. Let's look at that for the different schedules of reinforcement. This is variable ratio, fixed ratio, variable interval, fixed interval. And as you can see, the fixed schedules lead to not a straight rapid rate of response. In the fixed ratio, for example, often the animal will pause after a reinforcement and then start making the responses to get to the ratio, the fixed ratio that's required. If it's a variable ratio, then the animal does not do those pauses and has a much higher rate of responding. With the interval schedules, the same thing. With interval schedules, let's say it's a fixed interval 10 seconds, the animal will start out with a very slow rate of responding and then gradually increase that rate of responding up to the point which the reinforcement will occur. With the variable interval schedule, you don't see those changes in the rate of responding. You have a continuous high rate of responding. So variable schedules will lead to higher rate of responding than fixed schedules, and all of these schedules will lead to more responding than if you just reinforce on every trial. Thank you.